Alright, in this video we're going to take a look at some basics of logarithms, what logarithms mean, and how to evaluate some simple little log equations. So, let's start with the meaning of logs and what the abbreviation for log is log. So if you see an expression like this, what exactly does that mean? Well, just keep in mind that the log is the exponent. So what this is, it's a different way to write an exponential statement. In other words, this statement can be written as 5 to the second equals 25. Those two statements are identical. Now the exponent of 2 is always after the equal sign in a log expression. So the log is the power. Just keep in mind that the log is the power. So let's take a look at a couple other examples. How about 3 to the 4th equals 81? Well, if you were to write that as a log expression, you would write log 81, the answer. The base goes as a subscript, so the base is 3, and the exponent always comes after the equal sign is 4. And this is read, the log of 81 base 3 is 4. So all log expressions are read the same way. Let me draw some little arrows here. You go log of, so go to the top arrow first. The log of 81, come down here and say base 3, and then is 4. A couple other quick examples. Let's go 3 to the x equals 8. To write that as a log expression, that would be the log of the answer, which is 8, base 3 is x. And you'll learn how to solve that type of problem later for x. One more quick one. Let's go the log of 1000 base 10. Now this time let me leave off the equal sign. And think about that. You should know the answer, because what does this mean? This means 10 to what power equals 1000. Remember, the log is the power, so it's the power that you're looking for in this expression. You're looking for the power, and the power is 10 to what power is 1000, and that would be 3. So 10 to the third is 1000. So this equals 3. Now you'll see oftentimes no base. It'll just say the log of 100, for example. If you see that, the base is understood. It's kind of like a square root. The square root, you know there's an implied little 2 there. Well, if you see a log expression and there's no base, there's an implied 10. So if you see the log of 100, you just automatically know the base is 10, and that answer would be 2, because 10 to the second equals 100. All right, let's move on to some log equations. And I'll show you how to solve for x, where x is in different positions. Let's start off with this one. The log of 36 base 6 is x. First thing you might want to do as a beginner is write this as an exponential equation. So that would be 6 to the x equals 36, and then just think about it. 6 to what power is 36, and x is 2. Now, it's not always going to be an integer answer, and you'll see that type of problem come up later. Let's go the log of 4 base 4 is x. And you'll get to the point you do not have to write it as an exponent, but as a beginner you may want to just have a better understanding of what's going on. That means 4 to the x equals 4, and x equals 1. Let's move the x around a little bit. So instead of having the x after the equal sign, let's go the log of x base 2 is 4. Again, what does that mean? Remember, the base is the subscript. What comes after the equal sign is the power, and the x is the answer in this case, and 2 to the 4th is x equals 16. All right, let's move that x around. Let's see, we've had it as, let's put it as the base. Let's go the log. Well, let's just take that last problem and kind of move things around a little bit. Let's put the 4 there, and we'll put the x there, and we'll put the 2 there. Okay, what does this mean? It means x to the 2 equals 4. And you think, what number squared is 4? And the answer is 2. So the x can be in any position. It can be after the equal sign, it can be the answer to the log problem, it can be the base in the log. So let's try a few more, a little tougher problems. Let me scroll down and get a new page here. Down, down, go, 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 go. Let's go. There we go. All right, let's start with, the log of 32 base 2 is x. And can we do this without even writing it out? Let's think. 2 is the base. 2 to what power is 32 is what that means. And if you still can't do that, you can always write it out and think about it. You have a better look at it and think 2 raised to what power is 32. And yes, this comes out as an integer. The answer is 5. Okay, let's move our x around. How about the log of x base 3 is equal to 81. What does that mean? It means 3 to the 81 power equals x. Well, wait a minute, that one's going to require a calculator. A little too big on that, but the calculator will come in handy, and you will find out later how to use the calculator to solve log problems. But this is just an exponent problem, so you can just type in 3 to the 81st. And we won't do that because it's a huge number. But I wanted to contrast that with this problem. Looks similar, but they're entirely different. This one means 3 to what power is 81. And again, you have to think about it a little bit. And that answer is x equals 4. Now again, you will learn how to do that using a calculator in case you don't know that 3 to the 4th is 81. Which is really not that common knowledge. You can kind of sit there and figure it out on your fingers if you have to. But there's a way to do all these problems on the calculator using logarithms, and that's where we're headed. All right, let's take a look at a couple more examples of some log problems. Let's make it a little more challenging. Let's go log of 1/100th base 10. Now I'm going to leave off the x. I'm just going to say, what does that equal? Well, if that throws you a little bit, think of it as x. So in other words, you're looking for the exponent, so it means 10 to what power is 0.01 or 100th. And if you want to think in terms of fractions, which may be easier for you, 100th you can write as 1 over 100. Now what would the answer be if the 1 weren't there? What if it were, let's do a little dream here. What if it's 10 to the x equals 100? Well, that answer is 2, obviously. So whenever that answer is whenever the number is under a 1, it's going to be a similar answer. The answer is going to be 2, but it's going to be negative. Because remember, a negative exponent reciprocates. So 10 to the 2 is 100. 10 to the negative 2 is 1 over 100. Let's take a look at a couple more examples like that. That's a little trickier. Let's go the log of 1/8 base 2 equals x, meaning 2 to the x equals 1/8. Now what I say, just pretend the 1's not there. Think of it that way. 2 to what power is 8? Well, that's 3, but since the 1 is there, which flips it over, that means it's a negative power, negative 3. So that little trick works pretty commonly. Let's stick with some fraction problems for a minute. Let's take the log of 4 base 1/2 equals x. These are confusing for some students. So that means x 1/2 rather to the x power equals 4. Again, what I like to recommend is pretend the 1's not there. What if this problem were 2 to the x equals 4? Well, that's obviously x equals 2. But since it's a 1/2, that means it's going to reciprocate if you make the power negative, so it would have to be 1/2 to the negative 2 power equals 4. Remember, a negative power, again, reciprocates the base, so it's 2 to the 2 equals 4. So don't let those fractions throw you. Let's take a look at one more tricky fraction problem. How about the log of 1/9 case 81 equals x. Well, let's think again what this means. It means 81 to what power of x gives an answer of 1/9. Well, pretending the 1's not there, think about it as this. 81 to what power is 9? Well, 9 is smaller than 81, so that means it's a root, and 9 is the square root. So it would be 81 to the 1/2. That would equal 9. But the answer we're trying to get up here is 1/9, so that means our power must be negative because it's reciprocated to get 1/9. So our final answer is x equals -1/2. All right, from here we'll take a look at some more equations with logarithms, some that are a little more complicated, some where we'll have to go to the calculator. But that's all for this video.